All right, here we go. We're going to start doing like a little type of proof, right? If you see a number one, we are performing a reflection. Okay, we're going to do a reflection on triangle ABC. And I want you guys to try to explain to me why ABC and A prime, B prime, C prime, those two triangles are still congruent at the end. All right, what did I do with them? What transformation did we do? It's right up there. I did a reflection. Does a reflection change size or shape? No. So does that make, right off the bat, does that make sense that those two have to be congruent? I did a reflection. Reflection doesn't change size or shape, so they should be congruent. It's just a matter of the wording now. And I know this is very elementary schoolish by filling in the blanks, but this is the best way so for you guys to make sure you have every single detail that you need in this when you write it. All right. So why are triangle ABC, A prime, B prime, C prime congruent? Reflections are, what do we call them if it doesn't change size or shape? We've used this term already. Rigid motion. So reflections are rigid motions. That preserve, ready? Distance, aka side length, everybody. It preserves distance, the side length, and it also preserves what? Distance, side length, and what else about the triangles? The sides and the angle measures. So reflections are rigid motions that preserve distance and angle measure. Therefore, triangle ABC is congruent to its image, A prime, B prime, C prime. That's the setup. That's the setup of saying the two triangles are congruent. Say whatever you're doing are rigid motions that preserve distance and angle measure. Therefore, the triangles are congruent. All right? I wish it were that easy every time, but you are going to have to find out now what we're doing. Are we doing a reflection, translation? This is what you had on your homework. This is why I said it was going to be so important. So triangle ABC and XYZ, why are they congruent? So here we go. Now we have to figure out, how do I get ABC onto XYZ? This is what we did at the end of class on Friday, and you had a couple problems in your homework over the weekend. All right, I don't want to just tell you what it is. I need you guys to dig deep and find it. Remember my little tips, though, from homework today. If I go from A to B to C back to A, what direction am I going? Clockwise. All right, let's see. If I go from X to Y to Z, what direction am I going? Still clockwise, so probably what's not involved? A reflection. If I change the orientation, a reflection would be involved, but since orientation did not change, a reflection is not involved. So I'm down to translation and rotations. So I'm going to let you guys go to work here. If you want to talk with other people around you, God forbid, I know that's never going to happen, but if it ever, Friday was a good day. You guys started talking a little bit. So find me a transformation that does it. It may be one. Maybe you get more than one. Okay, how do I get ABC onto XYZ? And make sure you're specific. So if you're going to say the word rotation, you better have a degree measure attached. If you're going to say the word translation, you better have up, down, and how many units? Left, right. And it might just be one. It might be multiple ones. All right, find one. Want to give it to me? I'm sure we're probably all the same on this one. Nate, dog. This is a rotation of 180. Everyone agrees? Rotation of 180. Again, why 180? How many quadrants did you go through? 1, 2, 90 degrees a quadrant. So ready? Let's fill in the blanks. this transformation is a rotation of 180 degrees. And then here we go. Ready? Since, what did we just perform? Rotations. These fill in the blanks are going to drop here pretty soon. Since rotations are rigid motions, they preserve distance and angle measure. Thus, this is the best part of the today, is you get to make up your own word there when I drop the blanks. I had therefore, thus, anybody else? In conclusion, others? What else could we put there? Anybody? Ergo?
So it's
I thought you were going to be clever, but so triangle ABC is congruent to triangle XYZ. Therefore, thus is a good one too. Then. All right, ready to roll? No issues yet? All right, yeah. Spin her in. All right, next one. ABC on the A prime, B prime, C prime. First, we got to figure out what happened if we're going to prove them congruent. Okay, whoa, check, ready? ABC, what type of orientation are we working with there? A to B to C. Clockwise. Woo, what about A prime, B prime, C prime? Everyone see it changed? So probably it's going to involve a reflection. All right, that's the only way I change orientation. So probably a reflection is involved here. I don't think you can do this one in one transformation. I think you guys are going to need two here. And please, even if it works for 1 point, you got to check another point. At least try 2 points with your rule that you're writing down. Try 2 with your rule. All right. Explain to me, what'd you have here? Anybody want to take this one? Not a big. Anna, go ahead. What did you have?
Reflection over the y-axis and then a translation down 3.
Everyone all right with that? Reflection undergoes a reflection. Again, be specific in the y-axis and a translation down 3. Since, what are we putting here now? What are we putting in these? Keep what we've been doing. Keep to the script. Since, reflections and translations. are rigid motions. They preserve distance and angle measure. Thus, the two triangles are congruent. Triangle ABC congruent to A prime, B prime, C prime. Okay, we kind of get the script here because now you notice in the next one, the blanks are gone. Okay, that's on you. The blanks are never going to be there. All right. I just wanted to make sure they were there for these first couple so you knew exactly what we were looking for to write. All right, a little bit different. I'm going to tell you what's going to happen. We're going to do the double prime. Image of ABC after a translation 5 units to the right and 2 units up, followed by a reflection over this line, which we'll talk about. All right, so let's do the first one. After a translation 5 units right, 2 units up. Go ahead. Let's see where the new triangle is. So translation 5 units to the right and 2 units up. You can call this prime because look at our last one. They want us to call it double prime at the end. So if you want to call this prime, that's fine. Everyone have it translated before we do the next part. Followed by a reflection over y equals 0. All right, we can more than handle this. We've talked this unit. Y equals any number is what type of line? Horizontal, right? Now it's going to be horizontal through 0. Give me another name for this line. Horizontal line going through 0. They're just asking me to reflect over the origin. We've never reflected through a point yet, Spence. That's coming up later, but horizontal line, a line, horizontal line going through 0. That's another name for the x-axis. There you go. That's what I'm looking for here. Reflect over the x-axis. All right, go ahead. It doesn't say to state the coordinates, so we don't have to write what they are. It just says graph and label. All right, explain why they're congruent. No blanks here. First thing, tell me what we did. What did we just do to the two? Name the two transformations we just did. Translations. And we don't have to get, we don't have to get specific here that we went right 5 up 2 because it was already told in the directions. If you write it in, that's fine, but we don't have to get specific and tell me what you did because it was already in the directions. So translations and reflections are, I'm just keeping to the same script we had the last 3 problems. Rigid motions, which, the same thing every time, which preserve, oh boy, R-E or E-R? R-E. Which preserve distance and angle measure. Come on, somebody's got to have a good word. Anybody think of one? Thus, therefore. Henceforth. Oh, I forgot about that one. Henceforth. again, if you just want to put in conclusion, therefore, thus, henceforth, triangle ABC is congruent to triangle A double prime, B double prime, C double prime. Same script every time, except the only change may be you might have to tell me what you translate and what you reflect. That they're already in the directions, but if you make that up, you are responsible for that. You write that in. Okay, if you found the rule. All right, questions? Okay, so what are we doing about this week here? All right, here. Oh boy, I'm sure you're going to be so happy to hear this. All right, no school tomorrow, nothing changes. We just keep moving on. We're a day behind everything, okay? You probably will need your compass sometime this week, no matter if we have school tomorrow or not. Here's the issue though, what happens if we don't have school on Wednesday? Ready for this one? Tuesday, snow day, no big deal. No school on Wednesday. Visible to students. We're going to meet up, okay? And that's through the entire school too. All right, so it becomes a virtual day on Wednesday if we don't have school. Tomorrow's all good to go, but no school on Wednesday. We meet up, and there's the link right there on Google Classroom. That's the one we'll be using. All right? So that's the deal. And then when we get back, don't worry about the test or anything. Whenever we meet again, I'll talk about what the test will be. I'm not worried about that. I'll probably need a compass this week by the end of the week. And then again, if we don't have school on Wednesday as well, we're going to be linking up together. All right? All good? And yeah, I will be teaching. So if you happen to miss it, I guess the power situation would be a problem too. But if I'm able to get online, I do plan on teaching the next topic. So, all right, all good. Okay, you guys can get going with the assignment, which looks like it's in the packet today. Yes, sure.